We're looking at this session at the volume of a pyramid. Now, a pyramid, in this case, it's a square-based pyramid because it's got a square or a rectangle, often a square, but it could be a triangular base one. It could be any base that ends in a point. So a pyramid has any base ends in a point. So I'm just thinking about this. A cone is also a circular based pyramid because it's got a base and ends in a point. So this would also be a pyramid. Now, what you've got to remember about working out the volume of a pyramid is you need this height here, the perpendicular height. And that's key. Often with questions like this, when they get harder, they involve Pythagoras' theorem. And you've got to try and remember, again, Pythagoras' theorem. So in our toolbox, we should jot down the theorem that Pythagoras Samos came up with. And that is that this squared, that's one of the shorter sides, plus the other side squared is equal to the area of the longest side squared. So we can work out what this height is if we've got certain bits of information here. So sometimes you'll need that. Let's start with this one, with part one, slightly easier ones, and see what happens. Now, one thing that you should also know is that, and this is fascinating, every pyramid can fit into a cuboid. So if I draw a cuboid like this, and this is going to be one with a square at the bottom, what you need to understand, and I find this fascinating, is that we can fit, believe it or not, 3 of these in a cuboid. Now obviously they have to be in sand or some malleable substance, but 3 of these pyramids would fit into one cuboid. Why does that help? Well, because then the formula for this is going to be 1/3 of the cuboid. And the cuboid is the base, let's call it base, times the perpendicular height. So the volume is that. It's 1/3 times the base times the perpendicular height. And you've got to understand the perpendicular height, this tall height here, is the height of the cuboid. Not the slant height, this slant, but the height of that. And that's how you work out the volume of a pyramid. Let's use this as an example and we can go through it. So here goes. Hello. Oh, that's not working. Try one more time. There we go. Let's call this a square base pyramid. So let's call that 2 and that 2. And the perpendicular height, we'll say, is 8. And let's call this centimetres. It's a little ickle fella. So how do I work out the volume of this pyramid? Well, I find the formula. I've got the perpendicular height, tick. I've got the base, tick. So I can find the volume. It's going to be 1/3 times the base, which is 2 times 2, times the height, which is 8. So that's 1/3. 2 2s are 4. 4 8s are 32. So then it's 1/3 of 32. 10.67 centimetres cubed. And so that's how you work out the volume of a pyramid. When you've been told the perpendicular height, it's simply 1/3 of the cylinder. So it's 1/3 times the base times the perpendicular height. If it was a cone, it would be 1/3 of that base, which is a circle, times the perpendicular height. So the volume of a pyramid solved. Part 2, we're going to try and work out what the height is if we're given that slant. Hope you learned something.